how this is going to work. So we're going to alternate. So one of you is going to be the dealer and one of you is going to be the player, and then you can switch, or you do it 3 times if you're in a group of 3. So if you're the player, you're going to be dealt a card and you're going to record what the first card is. So it's either a king or an ace. You're going to put that here. Then you are not going to replace the card and you're going to be dealt a second card and you're going to place that here. You win if you get a pair. So if you get 2 aces or 2 kings, you win. And then you're going to record that win or loss at the bottom. And you're going to do it 10 times and you're going to do it for each of you. Okay? Go. Okay, so real quick, if you haven't already, right below your table, I just made up some examples for myself there. Right below, say based on your 10 plays, what your probability of winning was. So number of wins divided by 10. You can see I won 3 times in my imaginary world out of 10, so 0.3. Okay, everybody got that? Okay, good. All right, so we got our class data on the board. Based on our class data, what's the probability of winning? So let's add all those up. Careful with this, as we know. So, okay. 3, 2, 2, 1. That's a 3 at the end there. 3, 2, 4, 4, 4, 1, 7, 4, 7. All right, I got 62 total wins on the board we have. And there are 17 of you times 10 plays each. So out of 170, I get about 0.635. No, 365. Said that backwards. There we go. Okay. All right, good so far? Okay, so now we're going to kind of fill in some probabilities on this tree chart to see if we can figure out the actual theoretical probability of winning the game. That's an experimental probability, what we just calculated. Empirical is the word that our book uses. Okay, so it's called the ace game. So what is the probability if you have all 5 cards that the first card is an ace? How many aces are in that deck that you have? 2. So the probability is 2 out of 5. And you can always turn these into decimals if you want to. I don't feel like it's necessary right now. What's the probability that the first card is a king? 3 out of 5. At any point in time when you're doing these probability charts, the sum at any point in time should always equal 1 because it reflects all of the possible probabilities, and the most probability you can have is 1. Okay, so you can check that as you go down each of these columns. Okay, so now we know, let's assume the first card was an ace. So we take the ace out. What is the probability that the next card is an ace? It's a 1 out of 4. There's only 1 left in the deck, only 4 cards left in the deck. What's the probability that the second card is a king? A little bit bigger than that. A little bit bigger than that. 3/4. Yep. And those 2 are what's going to sum to 1 there. Okay. And then we have another scenario. First card is a king. We take a king out. What's the probability that the next card is an ace? How many aces are left in the deck if I take a king out? 2. 2 out of 4. How many kings are left in the deck if I take a king out? 2. Okay, and again, those 2 also add to 1. Okay, so now we want to calculate the over probabilities. Remember what I said yesterday? If we see the word and, we are multiplying. So this is the multiplication rule from yesterday. So if I want to know the probability the first card is an ace and the second card is an ace, I need to multiply 2/5 times 1/4, or 0.4 times 0.25, and I get 0.1. Okay. First card is an ace, second card is a king. I'm multiplying 2/5 times 3/4. I get 0.3. First card is a king, second card is an ace. So 3/5 times 2/4, or 1/2, is a 0.3. And the probability that the first is a king and the second is also a king. So 3/5 again times 1/2 will give me another 0.3. 0.3, same as last one. And if you sum all those up, again, you'll get 1. You want to check those probabilities. So now we can use this chart to answer questions. What is the theoretical probability of winning the game? So there were 2 ways you can win the game, right? You can get an ace and an ace, or you can get a king and a king. So winning probabilities are this guy up here, an ace and an ace, or this guy down here, a king and a king. Add those together. 0.1 plus 0.3. The theoretical probability of winning the game is a 0.4. That's pretty close to what we had as a group with our experimental empirical probability. We had 0.365. Okay? So this is about 4 out of every 10 times you play, which some of you, exactly, 4 out of times 10 you played. Actually, looks like that was the most common value on our board too. That's interesting. Got exactly that. Okay? What is the probability that the first card was a king given that the person won the game? Okay, this one's a little tricky. When you see the word given, it means you know something already happened and it's going to change the denominator. We know somebody already won the game. So we are focusing our attention on those 2 probabilities. We know that happened. Everything else in that table is irrelevant for us right now. Okay? So my denominator, my total is the 0.4 people, the 40% that won the game. Okay? Now I want to know the probability that the first card was a king. Okay? Well, out of those people that won the game, those 40%, 30% first card was a king, and 10% the first card was an ace. So 0.3 out of the 0.4 that won, first card a king, people that won. We know our numerator always has to be less than or equal to our denominator because our probabilities can't be bigger than 1, are going to tell me what's the probability that the first card was a king given that we know the person won the game. And I can get rid of those decimals real quick. 3/4 or 0.75 is the probability. So if you won 3 out of 4 times, it's because you had a king and then another king. Occasionally we've got the ace-ace combo. Any questions? Okay, so this is conditional probability that we're talking about. There are conditions that go along with what we're calculating. Things that have already happened. We saw this notation yesterday. If I see probability of B and then a bar A, it means the probability of event B given that A has already happened. If you see the word given, or you see event has already happened, or you see this notation, know that it's probably going to change your calculations a little bit. So on the back of your paper, I believe, you have these problems. Okay. It says 2 cards are selected from a standard deck of 52 playing cards. Find the probability that the second card is a queen, given that the first card is a king, and the king is not replaced. Okay, this is not a multiplication problem. We know the first thing already happened. If I wanted to multiply by something, the first thing would be a 1, because it for sure happened. That's the probability. Really, we're just calculating what's that second probability. Assume a king has been taken out. What is the probability now of selecting a queen? Well, how many queens are in the deck? 4. And how many cards are still in the deck because we're assuming that king was already selected? 51. And that is your answer. You can always turn it into a decimal if you want to. Okay? We're going to see a lot of tables in this section, especially when you get to Math Excel. The table below shows the result of a survey in which 2,276 social media users were asked whether they have been offended by something, posts, comments, or photos they saw on social media. Find the probability that the user is a male, given that the user was offended by something on social media. You always want to start with the given. We are given that the person was offended by something. So that part of the table is the only thing we're going to use for our calculations. And they nicely have put totals here at the bottom for us. If they did not have totals, you would have to find those yourself. So sometimes there's an extra step there. Okay, so people that have been offended by something on social media are here. Those are my yeses. Okay, so we're going to focus our attention there. We want to find the probability that the user is a male. Okay, so the total people that have been offended by something on social media is 1,151. The probability that they are a male, well, in that group, there are 532 males. And then we can always divide that and turn it into a decimal. Make sense? Okay. All right. See if you guys can do these ones at the bottom of your paper. Start with the given. The given is your denominator. That should, okay. These are relatively quick, especially when they give you the totals. So, given that they are male, there were 250 males total. Out of those, 116 contributed, and then again, you can turn that into a decimal if you need to. Find the probability that the randomly selected worker is female, given that they contribute to the retirement plan. 259 people contribute. That's the denominator. Females in that group were 143. All right, questions getting those probabilities? Okay, that's actually it for our lesson today. It's the only thing we didn't get to with 3-2 yesterday. So, I have an exit ticket for you. I'm not collecting it. We're just going to go through the correct answers as a warm-up at the beginning of the period tomorrow. At the top here, you guys are going to make a table diagram, kind of like we did with the king and queen example, like a little branch diagram, and that's going to help you with the questions at the bottom. Okay? All right, so you guys can have the last 20 minutes here. You can work on this. You can work on Math Excel. Remember, your 3-1 Math Excel is due tonight. I haven't finished that one yet. 3-2 is due on Friday. We've got one more lesson tomorrow, and then Friday is going to be a Math Excel work day for you guys. All right, and then you can, just before you leave, drop those cards back in the bin for me. Thank you, thank you. I'll do cell phone lotto.